Hello, everyone, and welcome to our first day of our new unit, which is going to be trig inverses. We're still going to be exploring the unit circle and looking at our trig functions of sine, cosine, and tangent. We're also going to look at secant, cosecant, and cotangent in this unit as well. So to start us off with trig inverses, we need to remind ourselves, what is an inverse? So I've gotten some notes written out here. If at any point in time you need to slow down, then feel free to pause the video. I just wrote things down ahead of time just for the sake of not making this video too long. So first, what is an inverse? Remember, that is when we switch our x and y values. So we take all of the x's and turn them into our y's, and then we take our y's and turn them into our x's. And then what happens is that we get a reflection over the y equals x line. So I've already graphed out a picture of a graph that we've seen before. Here we've got a parabola, x squared. And then if I reflect it over the line y equals x, then it turns into this dotted graph. The only problem with this graph, as we learned in first semester, is that when I reflect x squared, it's a function, but the inverse is not a function. Remember, the inverse here fails the vertical line test. So because I cross in two different places, the inverse is not a function. Why is it not a function? Because the original function is not, remember, what we called one-to-one. This would have to pass the vertical line test and the horizontal line test in order to be one-to-one. So how can we make it? Because remember, we've got sine and cosine. They are not one-to-one as they are. So we need to do something that we call restrict the domain. If we restrict the domain and only look at a portion of the original graph, then that can become an inverse or have an inverse. So if I look at x squared, if I only focus on the part that happens after 0, so 0 to infinity. So imagine I'm only going to focus on this one piece of the graph. So this part goes away. I only look at this from 0 to infinity. Well, if I take this graph, this passes the vertical line test and it passes the horizontal line test. So this portion of the graph is now one-to-one. I can reflect that over and it becomes this part right here, this top dotted line of the graph. And so that's what I'm going to do with sine and cosine. I'm going to restrict them in a way that gets rid of everything that doesn't work for me and then reflect it over that y equals x line to make it its inverse be a function as well. So we're going to do what we call restrict the domain. You're going to hear that term quite a bit today, okay? And so we're going to learn, how do we restrict the domains, and then what does it do for my end resulting graph? So we're going to start with cosine. So here I've already got some things drawn out for us. Here is my original cosine of x function that we learned when we first introduced you to trig functions. I have here the accompanying t-chart. When my angle is 0, then my cosine is 1. When my angle is pi over 2, cosine is 0. When my angle is pi, my cosine value is -1. When my angle is 3 pi over 2, I'm at 0, and 2 pi, I'm back at 1. So remember, here's my cosine. I start at 0, 1, and then I go down and then up. You know, this graph continues in both directions, although I've just drawn a portion of it. But right now, as this part of the graph is, this passes the vertical line test, but right now it fails the horizontal line test. So I'm going to restrict cosine's domain as close to 0 as I can. So I'm going to start here and I'm going to highlight. From here, I'm going to keep going until I no longer have that one-to-one. So I'm going to keep going. I'm going to stop right here at this minimum, because if I pass that minimum, this graph is going to start going upward, and then I'm going to start failing that horizontal line test. So I'm only going to focus on this first half of the cosine, period. Where is that in my t-chart? That's right here, from 0 to pi. this is what I'm going to restrict my domain. I'm only going to focus on the domain from 0 to pi. I'm going to ignore everything else. And this piece right here, this, I'll highlight it for you. These values are what I want to flip in order to create my cosine equation. So if I do my inverse and I switch these, then instead of 0, 1, this is going to become 1, 0. Instead of pi over 2, 0. Why did I do that? Sorry. It's going to be 0. I have to switch it. Pi over 2. And then instead of pi negative 1, I'm going to be at negative 1 pi. So I switched them all. Well, now let's graph this. If I graph these points, I'm going to be at 1, 0. So I'm going to have a point right here. I'm going to be at 0, pi over 2. And then I'm going to be at negative 1 pi. So those 3 points, although I don't want to draw a straight line, it actually has that curve to it. This is cosine. And I probably drew that y-axis a little too wide, but this is cosine inverse. So let's talk about the characteristics of this graph. Cosine inverse has a domain. How far to the left, how far to the right can I go? My domain is negative 1 to 1, inclusive because those points, endpoints are included. What's the range? How low can the graph go? It's going to start at 0. How high can it go? Now it goes to pi. So this domain restriction that I created over here became the range over here. Okay. Now the next thing that I'm going to note here, notation in this unit, you're going to see 2 versions of these inverses. You may see cosine to this negative 1 exponent. The negative 1 should be attached to cosine, not to the x. Cosine inverse of x, or we're going to refer to it as arc cosine. So whenever you see this arc in front of cosine, it means cosine inverse because we're referring to the arc that it covers. Okay, so that is cosine. Now let's talk about a few other things. What does this 0 to 2 pi? Because this is going to be important for me. Since I can only look at, I can only input values from negative 1 to 1, the only output values I can get are going to be from 0 to pi. So I'm going to introduce this term. This pi, 0 to pi, we're going to refer to as a principal interval. And we'll explain this more. But that principal interval is going to be important for me for this entire unit. Every trig function, every inverse, cosine inverse, sine inverse, tangent, they're all going to have a specific principal interval. So let's explore what this principal interval means. What does 0 to pi principal interval mean for cosine inverse of x? Well, let's take our unit circle. So I've got a sketch of my unit circle. I've got all my special angles marked. I've got my quadrants. Marked. What this means is that the output will only come from 0 and pi. Well, let's look at that angle or those angle measures on the unit circle. Where is 0? 0 is here. Pi is over here. So principal interval means that when I ask you for the inverse value for cosine, the only possible angles you can give me are going to happen between 0 and pi, which means they're only going to come from quadrants 1 and quadrant 2. So the output would only come from 0 to pi or quadrants 1 and 2. Okay. Now let's think about that a little bit more. So for cosine, remember cosine is asking for the x values. So when I ask for these, or what this will look like, is when I ask for cosine of x is going to equal an angle. We're going to work backwards. See, before we went from what was the cosine and we got a value. Now we're switching it. Remember, we're switching x and y. So I'm going to ask you for the value. I'm going to give you this. You need to work backwards and give me the angle, okay? So let's say, for example, if I ask you for cosine inverse of 1/2 equals an angle. So in other words, you can look at this problem as cosine of what angle is 1/2. Okay, well, let's think at our, let's think about our special angles around the unit circle, right? We know it's only going to come from quadrants 1 and 2. If I think about all the coordinates, remember my coordinates for, I want to know, when is the x positive 1/2? That's going to be right here, 1/2. Those are the coordinates. That's pi over 3. Remember, we got to remember our special values. This is where I get positive 1/2. Now think it's also positive 1/2 down here. Here I have positive 1/2, negative root 3 over 2. But this value is not in my principal interval. It's not from quadrants 1 and quadrants 2. So although there are 2 places on the unit circle where cosine is equal to 1/2, because I have restricted the domain, I can only give the output that falls between 0 and pi, which in this case would be pi over 3. And I think I'm getting ahead of my notes. So I'm asking at what arc is the cosine value 1/2? Again, I did get ahead of myself. Again, we're here. It happens in quadrant 1 at pi over 3. Okay, let's try another one. Here's that different notation, arc cosine of negative root 3 over 2. I'm wanting to know the cosine of what angle equals negative root 3 over 2. Well, cosine again is referring to the x value. Where are the negative x's? Negative x's happen in quadrants 2 and quadrants 3. But based on my principal interval, I can only give output values that are in quadrant 1. So I'm going to ignore quadrant 3. So think about your unit circle. Think of your special values. Which of those have coordinates for the x of negative root 3 over 2? That's going to be this guy right here, which is what? 5 pi over 6. Okay, so think backwards. We're switching. We're asking now, if this is the x value, what is the angle that gives me that x value in the correct quadrant? Okay, so for cosine, again, possible output values only come from quadrants 1 and quadrant 2. All right, let's move on. Let's talk about our next graph. We're going to talk about sine this time. Let's switch out my paper. So in the same way that we graphed cosine, here I have a graph for sine. All right, we're going to do a little bit more manipulating when it comes to this one. So here is first a period of sine, starting from the origin and going to 2 pi. So if I try to do what I did with cosine, remember, right now it passes the vertical line test, but it fails the horizontal line test. If I start at 0 and go up, I'm only going to get a portion of this graph before it starts to fail the horizontal line test. So I want to actually continue this graph into the negative side. So I want to graph, where is it at negative pi over 2? That's why I've kind of left a space over here. At negative pi over 2, it's at negative 1. And then it's going to go back up to 0 at negative pi. So this graph goes like this, and I can keep going if I want to, but I'm not. Okay, so there is the continuation on the left-hand side. Okay, so there I'm at negative 1 at negative pi over 2. So I want to try to keep this as close to the y-axis as possible. So just like we restricted the domain for cosine, where's my original little note here? So here we restricted cosine to be this little sliver from 0 to pi. I kind of want to identify the same thing here. The only thing is I don't want this one that's not on 0. I want to include that 0. So I'm going to focus on this sliver that goes into the negative and into the positive. So that little sliver right there. What is the domain of that? Domain of that little sliver is negative pi over 2 to positive pi over 2. So I'm going to restrict the domain and only focus on that interval. So in terms of my t-chart, just like I focused on a certain portion for cosine, I'm only going to look at these values right here. The negative pi over 2 to pi over 2. Oh, I'm sorry, you can't. Highlighter is a little difficult to see. I want to focus on these values, okay? So I'm going to switch those pieces. So if I have my little t-chart and I swap those, negative pi over 2 and negative 1 is going to turn into negative 1, negative pi over 2. 0, 0 stays 0, 0, so that works. And then pi over 2 comma 1 turns into 1 pi over 2. So now here are my 3 new points that I'm going to graph. Negative 1 and negative pi over 2. I'm going to go here, negative 1, negative pi over 2. So I'm down here. Then 0, 0 just remains on the origin. And then pi over 2 comma 1 is right here. Again, don't just make a straight line. We've got to curve these. So this is going to go down, and then this one's going to slightly curve up. So this is my sine inverse graph. Let's talk about these characteristics. The domain, how far to the left, how far to the right does this go? It goes from negative 1 to 1. What's the range? The range, it goes from negative pi over 2 to positive pi over 2. Again, that negative pi over 2, positive pi over 2 comes from the original domain restriction that we restricted sine to in order to have an inverse that was a function. Okay? Which means now is that this negative pi over 2 and pi over 2 to pi over 2 is sine's principal interval. So it's going to be different as far as the quadrants that it covers compared to cosine. Okay, so if I look at my unit circle, here's my unit circle, the principal interval is going to go from negative pi over 2 to pi over 2. So if 0 here is on the x-axis, negative pi over 2 means I'm going in the clockwise direction, which means I'm going to cover quadrant 4. Positive pi over 2 is going to cover quadrant 1. So as far as sine goes, I'm going to focus on these values, only those angles, okay? What angles are they? And I could have written it for cosine, sorry that I didn't, but that's pi over 6, pi over 4, pi over 3, and then going this way, we've got 11 pi over 6, we've got 7 pi over 4, and those are the positive values. Sorry, I should be doing the negative values, my bad. So negative pi over 6, negative pi over 4, negative 5 pi over 3. Okay? Which these are the ones we will want to use. So we know them as the positives, but we need to express them as negatives when we go with them, or when we evaluate. Okay, so arc sine, remember that's the same thing as sine inverse of 1/2. They're the exact same thing. I want to think what sine angle gives me 1/2. Well, remember sine is y. So in terms of these angles, which of those angles have a y coordinate of positive 1/2? What do you think? Hopefully you thought pi over 6, because that's what it is. The coordinates for pi over 6 are positive root 3 over 2, positive 1/2. So this is pi over 6. Now, if I had sine inverse of 2, again, think sine of what angle gives me a coordinate, a y value of 2. Well, think of all your coordinates. I don't have one. There isn't a y value of 2. Remember, the y values only go from -1 to +1. So since there's no sign value that gives me 2, then that is no solution, not possible. No angle, I'll say no angle gives me 2. So we just say it's no solution. Okay, let's try another one. Arc sine of -√3/2. So again, arc sine is the same thing as sine inverse of -√3/2. Which of these special angles have a y coordinate of -√3/2? What do we think? That's going to be right here. The 5π/3, but I'm going to express it as a negative since that's my principal interval. Has to be between -π/2 and +π/2. So this is going to be -π/3. I'll say angle, I'll write this angle has to be between -π/2 and π/2. So although 5π/3 is coterminal with that, the answer needs to be expressed in terms of the principal interval. So I only want to put values that are in between these numbers. Okay? One more for sine, and then we'll move on to tangent. Sine inverse of -1. Sine inverse of -1, again, so we're asking ourselves what angle, the sine of what angle is -1? Which angle has a y value of -1? Well, hopefully you said -π/2 because that happens right here. These coordinates, 0, -1, that's -π/2. Okay? Excellent. Moving on, we're almost done. The last inverse that we're going to look at is tangent. So in the same way, I have graphed already what tangent should look like. Here is one period of tangent. There we go. There's the the t chart to go with it. Tangent, unlike sine and cosine, have asymptotes. They happen at all of the half pi's. So -π/2 and +π/2 have asymptotes, which is why they don't have values here. And then the values in between, we've got -π/4 to 1 and -1. We've got 0, 0, π/4, and 1, and then there's my next asymptote. Okay. Taking a look at this, this is just one period of the graph. Is this one-to-one as it is already? Yes, it is. It passes the vertical line test, and it happens to pass the horizontal line test. Now, that's only because I've graphed one period. Remember, there are other repeats of this on both sides. Boom, boom. Sorry, I'm not graphing them all. But together they fail, but this one period by itself does pass. So we're going to keep that one period as the principal interval right here. So this right here is my principal interval. So I'm going to actually consider the whole thing in terms of my XY t-chart, okay? And when I graph this, or when I switch my X's and Y's, so I'll put my Y's here, I'll put my X's here. These are still going to be asymptotes, but now they're going to be horizontal asymptotes. So this -π/2 is going to be a horizontal asymptote at -π/2. -π/4 is going to turn into -1, -π/4. 0, 0 stays. π/4 becomes 1, π/4. And then this vertical asymptote turns into a horizontal asymptote at π/2, positive π/2. which means now, if I graph this, I'm going to have a horizontal asymptote at positive pi over 2. I'm going to have a horizontal asymptote down here at negative pi over 2. And then negative pi over 4, negative 1, 0, 0. And then pi over 4, or 1 pi over 4. All right, so here's my graph as best as I can. Sorry, that looks terrible. There we go. There is my tangent inverse. Now notice, unlike the others, these aren't endpoints. This is going to keep approaching that horizontal asymptote in both directions. So this will go infinitely in both directions. What does that mean for the domain? That means tangent inverse actually has a domain of all real numbers because I'm not restricting it. It doesn't have endpoints. My range, however, I'm going to keep approaching both of these dotted lines. I'm going to keep approaching those horizontal asymptotes, which means I'm not going to have them inclusive. I'm still going to go from negative pi over 2 to positive pi over 2, but I'm going to have soft brackets around those values because they are not included. So I can get as close to that pi over 2 as possible, but those endpoints are not included. In cosine and sine, they are included. Okay? So now let's evaluate in this end. So here's my graph. Again, or sorry, a little sketch. Let's talk about the principal interval for tangent. Sorry. Okay. So tangent inverse of negative 1. So remember, tangent is the reciprocal of y over x. So we have all the ratios with all of these values. When I make that ratio of the y coordinate over the x coordinate, when does it reduce to negative 1? Well, because for our quadrants, if I'm going to go from negative pi over 2 to pi over 2, again, that means I am only focusing on quadrants 1 and 4. I'm only concentrating on these and these. Not 1 and 2, not 1 and 3, only 1 and 4. So of these two quadrants, when I make a ratio of the y over x, when does it reduce to negative 1? Well, to become 1, it's going to mean that the x quadrant coordinate has to match the y coordinate. Remember, that happens at either pi over 4 and negative pi over 4. But which one gives me the negative 1? That's going to be negative because on this, remember, we've got positive root 2 over 2 for the x, but then negative root 2 over 2 for the y. And when I put negative root 2 over 2 over positive root 2 over 2, that gives me negative 1. So tangent inverse of negative 1 is negative pi over 4. Okay. For arctangent of root 3, think back to our tangent values. When does that happen? What angle gives me a y value of root 3? Well, hopefully, if you remember your little tricks, anytime I have a root 3, that means I'm using a denominator. It's coming from a special angle that has a denominator of 3. So that could be positive pi over 3, or it could be negative pi over 3. If this value is positive, that's going to come from quadrant 1. So this is going to be pi over 3 right here. Now again, if you don't remember that pi over 3 has a tangent value of root 3, you got to memorize your unit circle values. Why is that? Remember, the coordinates for pi over 3 are 1/2 comma root 3 over 2. And if I make a ratio of root 3 over 2 over 1/2, that's going to reduce. I'm going to multiply this. Those are going to cancel, and I'm just going to get root 3 as my tangent value for pi over 3. So those unit circle values that you had to memorize before, they're still going to be used. Okay, so those are all three of our trig inverse functions. Now, we're going to ask you to graph them. So make sure you familiarize yourself with how the original graphs look. So there's my cosine or sorry, there's my tangent, excuse me. We had our sine here on that previous page, and then the first one we did was cosine. If I can find the graph, there it is. There's cosine. The other thing that we will ask of you is to evaluate. Evaluate means tangent inverse of a particular value equals what angle. So you have to think back to your coordinates, your quadrants. A very helpful hint, kind of a little sentence that some pre-cal teachers have used to help you remember where the values come from. If you remember this statement, you have to be on the right side of the sign to get a good tan. Or really, you've got to be on the right side of the sun, but change the word sun to sine to get a good tan. What does that mean? Well, let's think of our quadrants. If you think of the unit circle as a sun, a circle, a sun, the right side of the sun is quadrants 1 and 4. Sorry, I'm using a yellow highlighter and I guess you can't see it. So there is the sun right here. Trying to change my angle. Oh, that goes away. There we go. There's the yellow. Quadrants 1 and 4 with values from pi over 2 to negative pi over 2, or sorry, the other way around, negative pi over 2 to pi over 2. This is for sine and tangent. That's where your values can come from, sine inverse and tangent inverse. Cosine, although we don't have a special sentence for cosine, cosine is the top, right here. Quadrants 1 and 2 only. Helpful hint, quadrant 3 is nothing. No one gives me values from quadrant 3. So your angles will only come from quadrants 1 and 2 for cosine, and from 1 and 4 for sine and tangent. Okay? I know this is a little bit more tricky lesson. Please let us know if you have any questions. Please review this video if you need to go back and check anything. If you have additional questions, ask your teacher or see us in tutorials. Thank you.